Paper 2, it's usually statistics. And they're telling us that Miss Murphy decided to research the effectiveness of her online classes. And then she divided the 12 pupils fairly into 12A and 12B. So 12A attended face-to-face classes, and then 12B attended the online classes. Then both classes were taught by the same person over the same period of time. And then they are telling us that the table below shows the time spent teaching in hours, and then the average results of the learners' weekly tests as percentages. Okay, so this is a bivariant type of data. So we look at the time together with the results, and then the time together with the results. Okay, so time is the independent variable, whereas the results will be the dependent. Then they ask us to determine the equation of the least square regression line of 12A. So we just need to capture this within our calculators. Remember, the steps are quite clear and simple. So we said we always have to start with the mode. And then from the mode, you choose the start. Then after getting the start, we need to look for the A plus BX times it's a small a and a small b x. And then we shall get a table, which table will have the X on one side and then the Y on the other side. So what we said was that the first row will always indicate the X values or the independent variables. So we enter this, we capture that. So 2 equals signs 8 equals signs 4 equals signs 6 equals signs 12 equals sign 10 and 11. Then we also enter the Y values, 42, okay, then we have a 62, and then a 48, then a 52, a 64, 63, and then a 67. So capture that. When all those values are captured, then we can use the on button or the clear all button so that everything disappears. Then we need to press shift and then 1. So shift and 1. Then we're gonna go to 5 that talks about the regression. And then that 5, we can look for the values of A and then the values of B. I think it's option number 1 and then option number 2. So if that is done, our A that we're gonna end up with is 38,26. That's what I'm getting, 38,26 from my calculator. And then the B that I'm having is a 2,456. Let me just round it off to decimals. So it's a 2,46. So remember, our regression must always be in the form of A plus BX. Okay, so when I write that out, it's going to be 38,26 plus 2,46 times X. So that's all they want there. Then 1.2, they want us to write down the correlation coefficient of 12A results with respect to the time. So what we need to know is that these values, since we entered the values of 12A, we can just go back, you press your shift, and the 1. Then we go for the 5, which is regression. And then we go for option number 3 on my calculator that is representing the regression symbol. On your calculators, look for that option, the small r. So my regression is 0.966, which is like 97. Okay, so that is what I'm having. Then 1.3, they want us to comment on the correlation between the time spent. So whenever we are commenting, we look at the value. Okay, the value itself is going to tell us the strength, and then the sign of the value must give us the direction. Okay, so in this case, since it's 0.97, that is a very strong, okay, but it is positive. So a very strong positive relationship. Okay, so that is what we have to do. Okay, so that is 1.3. Then when we look at 1.4, they're telling us that the equation of the least squares of regression of P is given as this. Okay, we need to calculate the difference in the result that is achieved by each class. Had this lady spent an average time to complete a particular lesson. So the key statement here, because we need the value for the time, but they are telling us the average time. So we know that average is the same as the mean, and sometimes we denote it as x bar. So if we go back to our table, we go back to the table that we were given. We have 2, 8, 4, 6, 12, and so on. Let's quickly get the mean for those values. So it's a 2 plus 8 plus 4 plus 6 plus 12 plus 10 and then plus 11. Okay, and then I'm going to divide this by 7. So I got a 53/7. So our mean time that we're talking about is basically 7.57. Now they want us to use the 7.57, substitute it into this regression equation as well as this one, and let's get the difference between the two. So for the first case, for 12a, if I use that line, I'll have my y as 38.26 plus 2.46 times the 7.57. Okay, let me just get my answer. That is plus 2.46 times. That's giving me 56.88. Okay, then let me do the same for 12b. I'm having 15.74 plus 4.54 times the 7.57. Okay, so 15.74, 4.54 times 7.57. I'm getting 50.12 from the round off. Then we need to just subtract these two values since they asked for the difference. So guys, in maths, when they ask for difference, don't write explanations and tell us this is bigger than that, or it's just the subtraction. So 56, we're gonna have 6, having 76. Yeah, something of the sort. Then 1.5, they want us to identify any outlier or an outlier in 12p. So an outlier, we say it is an extreme value. It's either too small or too big compared to the rest of the data. So in this case, the outlier will be a 9 for 12p because it is basically the lowest mark. So how do we indicate that? You have to write us the time that it took place, and then the 9. In other words, the time that was taken to teach this person, and then the results that they got. Then indicate a valid reason for this outlier. Remember, the outlier is falling under the online classes, if I'm not mistaken, because 12B attended the online classes. So we can talk of any valid reason that could come up as a result of online classes. Okay, what problems do people face? Maybe this person couldn't even attend because of load shedding, because of poor connectivity, or this person had their own reasons. But what are those reasons? Okay, so we can just attach it to maybe lack of attendance. Just that. It's lack of attendance because of ABC reasons. All right, so that is 1.6. That is the whole of question 1. Let's look at question 2. Formula 1, the race car drivers have to endure high G forces at extremely high temperatures, and then they tend to lose almost 4 kilograms of weight after every race. Oh, that's too much. 2.1. 2.1. The table below shows the total weight that is lost by 40 different race car drivers after the duration. So we have this grouped data of ours. Okay, we have the classes of the weight loss and then the number of drivers that lost weight. Then they want us to determine the modal class. So a modal class is basically that class with highest frequency. Now remember, the number of drivers will represent the frequencies. So these intervals are representing our classes. So the highest frequency that we are seeing is the 15. So this interval becomes the modal class. So we're going to say 2.5 is less or equal to the weight and less than 3,000. Then they want us to calculate the estimated mean weight loss of the drivers. Okay. So remember, it's a process that was done way back in grade 10, but I'll just try to push it there first. Okay, so we had the X, which X was the midpoint of the class intervals. And then this was the F of X, the product of the frequency, and then that. So we already have the total number. So this is summation of F, the frequency. We know that the estimated mean, which is the mean of this grouped data, will always be given as the summation of Fx over the summation of F. So in other words, we need to get the product of the frequency and the midpoint first, which is a bit different from the one variant kind of data. So how do we get the midpoints? Midpoints are obtained by just adding the upper class as low as and the lower class. So it's 0 plus 500, and then we divide by 2. So this is going to give us a 250. Same story, 500 plus 1,000, then you divide by 2. You're going to get something like a 750. So when you look at the trend that is happening, it's like we are just adding a 250, 250, 250, 250 everywhere. So this is going to be 1,250. And then this is going to be 1,750. And then it's going to be 2,250. And then 2,750. And then 3,250, something like that. And then if we multiply the 250 by the 1, we shall get a 250. 750 by 2, we shall get a 1.5. And then 1,250 times 3, we shall get that 750. And then 1,750 times 8, we're getting 14,000. And then 2,250. 2,250 times 6, that is 13,500. And then 15 multiplied by 2750, that is 4,1,250. Okay, and then 5 times 30 to 50. That's giving me 16250. And then what I need to do is just add up. I need to get the total of all these items. Okay, so let me do that. 1.5, I have 3,750 plus 14K, 1,500 plus 41250 plus 16250. So my total here is 9,500. Okay, so my estimated mean, let me just write this side. This is Christian number. Okay, so estimated mean, saying summation of f for x over summation of f. So you have 9,500 divided by 40. Okay. So when I divide this by 40, I'm getting 2262,5. So this is basically the grams that were lost on average. All right. Then 2.2. They're telling us that the recording of the weight lost within the second race was made 1 month later. And the amount of weight lost in race 2 was k grams more than in race 1. Okay. It is given that the maximum value of the ogive representing race 2 was 40 and 3504. And then the graph was grounded at 40. Okay. Then they want us to sketch the ogive or the cumulative frequency curve representing race 2 within the answer book. So this table is for which race? They don't tell us. Just looking at the second table. Okay, so what we're going to do with the cumulative frequency, we know that we normally use the cumulative values. Okay. I've used almost my table. Okay. I'll use this other one here. Try to decrease it and decrease it a little bit. Okay, so if this is my table, let me try to indicate the value of the cumulative. If that is gonna make sense. Let's see. Okay, so with the cumulative, we know that the first cumulative will always be the first frequency. Remember, we say this is frequency. So this is for cumulative frequency. And then 1 plus 2, we must get a 3. And then 3 plus 3, we must get a 6. And then 6 plus 8 is a 14. 14 plus 6 is 20. 20 and that, we get a 35. 35 and 5, we get a 40. So our last cumulative must be equal to the total frequency. Then, if we go back to what they told us, this condition of theirs, they told us, remember, these values are for race 1, but we want to play around with this to create the race 2 values. Telling us that the recording of the race was made 1 month later, and then the amount of weight lost in race 2 was k grams more than in race 1. Okay. It's given that the maximum value of race 2 was 3504 as well as a 40. And then the graph was grounded at 4 and 0. What does this mean? It simply means that the lowest interval is going to be F4. And then this one will be F504. So that when you subtract, you still have the same thing. Then the process continues. Okay, so this will be a 504, and then this will be 1004. 1004, and then 1504, 2004, 2504, 3004, 3504. You can see how it's coming up. And then these numbers will be the side. So 1504, 2004, 3004. This is a 2, sorry. It's a 2504 and a 3004. Okay, so we have that. We have the cumulatives. We just need to plot our graph. Okay. So which means that's going to be, they say they are grounding it at that. Remember, when we are plotting our graph, we normally use the upper classes. Okay, so these classes are what we use against the cumulative values. Okay, so the first one, which is going to be 5004, goes with 1. 5004 goes with 1. 4, 6, 10. So 1 is somewhere there. And then 1004 is going to go with, we said it's a 3. Let me just reduce this that I can see nicely. It's a 3, 6, 14. Okay. So that is a 1. We need a 3. 3 somewhere there. 6 is somewhere there. And then 14 is somewhere there. Okay, then from the 14, we have 20, 35, 40. So this is a 20. This is a 35. And then we have a 40. Somewhere there. All right. And then all you do is just connect this using your freehand. Using your freehand. And then you'll have the ogive as they want it, or the cumulative frequency. Something like that. Okay. Then they're asking us that how will the race of race 2, or how will the range of race 2 compare with the range of race 1? Now, the fact that we're seeing that the intervals are just varying in the same format, just a -4 and then a +4, something like that, or +4 on either sides, there's not going to be any difference, because remember, with the 0, we added a 4 to give us this. And then even with 500, we added a 4. So if you ask for the range, which is the maximum minus the minimum, there's no difference. Okay, you can say it just remains the same. It remains the same. And then determine the average weight that is lost in race 2. Average weight that is lost in race 2. So since we got our average, remember mean is the same as the average. We got it as what? Someone remind us. We got it as 2262,5. 2262,5. But then remember, we are adding a 4 for the lower class, and then we are also adding a 4 to the upper class, which means overall 4 plus 4 is 8, divided by 2, it's 4. So overall, we are adding 4 grams. So you're going to say +4. And then that's going to give us 2266,5 grams. That will be the mean or the average. All right, question number 3, which is the analytical geometry. So in the diagram below, we have A, which is negative 3K, and then B, which is 4,8, C is 50, D is negative 4, are vertices of parallelogram. So when they talk of a parallelogram, please let's remember the properties of parallelogram. Okay, we know the opposite sides are parallel, opposite sides are equal, but what is very important is that the diagonals bisect each other. In other words, the midpoint of this diagonal is the same midpoint of that other diagonal. Okay, so diagonals do bisect at P, and then the angles of inclination AB are alpha and beta, respectively. AB cuts the x-axis at P, and then F is a point within the fourth quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. There is F. Okay. Then they want us to get the gradient of BC. So we know that gradient is normally obtained by the change in y over the change in x. y2 minus y1 over x2 minus x1. So when you look at the BC, we have 4,8 and then we have 50. So that's going to be, let's say, 8 minus 0 over 4 minus 5. So that is 8 over negative 1, and then our gradient becomes negative 8. So that is the gradient that they need here for BC. Then if the distance between A and B is root 65, can we determine the value of K between A and B? This is root 65. So when they talk about the distance between points, then we're going to use the distance formula. Okay. And we know that the distance formula is, I'll say AB is the square root, or AB squared is all of that. X1 minus X2 squared, and then Y1 minus Y2 squared, or X minus X1, whichever format you use it, guys. So where there is AB, I'm going to use root 65 is equal to the square root of, I'm going to say, negative 3 minus 4 squared plus a K minus 8, but squared. And then I'm going to get rid of the square roots. You square both sides, and then the roots fall away. Okay, so I have a 65 is equal to minus 3 minus 4. It's going to give me negative 7. I square that. I have a 49. When I open this up, I can use my FOIL, K minus 8, and then K minus 8. So that's a K squared minus 16K plus 64. I'm going to regroup this and create what we call a standard quadratic. So I have K squared minus 16K. 49 and 64 is 113. When I subtract 65, I'm getting a 48. I can factorize that out, or I can use my quadratic formula. So which numbers? 48. Can use 12 and 4. Can say K minus 12, then K minus 4 is equal to 0. So either K is a 12 or K is a 4. So we already have the K. Whoa. What's happening? What is happening? Did we mess up with the signs? Did we? Something is not right. No, it's fine. It's okay. We didn't mess up. Remember, K represents the Y values, and both numbers are. Yeah, that's what it's giving us. Either K is a 12 or K is a 4. Oh, that's correct, guys. No need to stress. But when we look at where k is. This k is below the 8. So k cannot be a 12. This simply means at y12, the distance between A and that point is still going to give us root 65. So in this case, since we are saying that k is below this 8, then we're going to take k to be a 4. Okay, so I'm saying k is a 4. That is according to the interpretation of the drawing. Then 3.3. Can we prove using analytical geometry methods that BP, where is BP now? BP, where are you? Okay, that BP is perpendicular to AC. We prove that BP is perpendicular to AC. So for us to prove that, do we need the coordinates of P? We don't need that. I don't know. We can even use the coordinates of D since it's still the same straight line. I suppose we can use that. But what we know about perpendicular lines is that the gradients, which means the gradient of BP times the gradient of AC, it must give us a -1. So this is the condition that we should aim at. Okay. So what I'm going to do, just gonna move this side and say that the gradient of AB, is it AB or BP? Say the gradient of BD, let me use BD. Say y2 changing y over changing x. And then our BD is 8 and -4, 4 and -2. So I'm going to say 8 minus -4 over 4 minus -2. When I simplify that, I have a 12 over 6, which gives me a 2. And then the gradient of my AC, so changing y over changing x, same story. So with my AC, I have a -3 and a 4. And then I have 5 and a 0. So that is going to be so gonna say -4 minus 0 over -3 minus 5. So this is -4 over -8. Did I do something wrong? Say -4 minus 0, -3 minus 5. That is fine. Okay. This is giving me a half. With the previous one, did we do anything wrong? It was 8 minus -4, which is that. Something's not right. Something I did wrong here. Why am I using a -4 for the y? It's a positive. And see that. So that's a positive, and then we end up with a negative. Yeah. Then if we get 2 times -1/2, that gives us -1. Then we can draw the conclusion that therefore AP, because that was they said, no, it's BP. So BP is perpendicular to AC. All right, then calculate the coordinates of F. If it's given that AC, AC, just use a different color. Okay, ACFD, okay, is a pyrogram. Okay, so if this is a pyrogram and we need to find any missing coordinates, we have to use the midpoint. Okay, so we're seeing that this DC is a diagonal. So we need to find the coordinates of the midpoint here. So for us to get those coordinates, we shall say -2. Okay, let me just put it this side. So we're saying the midpoint of DC, midpoint of DC will be x plus x1 over 2, and then y plus y1 over 2, or y1 and y2 over 2. Okay, so we see -2 and 5, -4 and 0. -2 and 5 over 2, and then -4 and 0, plus 0 over 2. Okay, so when we simplify this, we have a 3 over 2, and then we have a -1. That is our midpoint. Then, what we said was that if we draw this diagonal also, the diagonal AF, this is also going to be the midpoint, which means if I call the coordinates of F to be X and Y, if I get the -3 plus the X divided by 2, I must get the 3 over 2. And then if I get the 4 plus this Y divided by 2, I must get -1. So let's do that. We're saying -3 plus the X of F over 2 must give us this X coordinate of the turning point. Multiply through by 2. So by 2 by 2. This cancels that. This cancels that. Move the X move the 3 that side. So X is a 6. And then we're saying Y plus a 4 divided by 2 must give us -1. Multiply through by 2 also. This cancels. So Y is -2 minus 4, which gives us -6. So which means F is going to be 6 and -6. So those would be the coordinates of F according to the question. So remember, you're looking for missing coordinates. In most cases, we use the midpoint, depending on the values that we have. Did we do this correctly? This was a 4. Whoa, 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 whoa. Is that true? Is that true? Is that true? Is that true? Someone is complaining, saying there's something we did wrong. So Y plus 4 over 2 must give us, so, oh, the midpoint. Guys, let's go check our midpoint values. Someone is not happy. Happy. Okay, so with the midpoint, remember we said midpoint. What was our midpoint? We said -4 plus 0 divided by 2. That's all. This was our midpoint, which gave us a -2, not a 1. Yeah, it's making sense. So it's a -2, guys. Sorry. And then if this is a -2, then that's going to be -4. -4 minus that is going to give us -8. So that is -8. Thank you very much. Then 3.4 is done. Then they want us to get the size of EDO, correct to 1 decimal place. EDO. Where is EDO? Let's change this. Something like EDO. This is E. This is D. And this is O. EDO. So they want us to get this angle here. So for us to get this angle, we need to first of all get the angle alpha. Okay. And then we also need to get the angle beta. So we know that this angle beta is going to be the same as this angle. It's the same thing. which means for us to get this angle of ours, we shall have to combine this angle and the beta to give us the alpha. So we got the gradient of BC, which was -8. But this gradient is the same as the gradient of AD. So let's use the inclination formula. So we know that M is equal to the tan of alpha. Our M is -8. So alpha is going to be the arctan of -8. Okay, if I substitute that, I'm getting -82,875. I will just add 180 to get the positive angle, which is a 97,13 degrees. Let's look at the beta. If this is 8 and it's passing through the origin, so the gradient is going to be 8/4, which is a 2. Someone can use 8 and -4, which will give you a 12, 4 and -2, which will give you a 6, to still give us a 2. So I'm going to say that my beta is going to be the shift tan of a 2. So shift tan of a 2 is giving me 63,43. So this angle is a 63,43, and we say it's the same as this because they are vertically opposite. This we got as a 97,13. So when we get this 63,43 plus this angle must give us that because of exterior angles of a triangle. So we can just quickly say that for us to get the ADO, okay, so ADO will be just the difference between the two, 97,13 minus 63,43. When we subtract that, 97,13 minus 63,43, I'm getting 33,7 degrees. Just that. Or is that 3.4? I'm just misaligning the questions. Yo, guys, I'm sorry. That is 3.5. That is meant to be 3.5. Okay, this is meant to be. Okay. Then 3.6, they want the area of ADC. A, D, and C. For max. So what do we know? What do we know? What do we know? Remember from the area rule, we must have two sides known as well as an angle. And let me just clean up this drawing. Just clean the drawing up so that we have a clear view. Okay. So then they want us to get area of ADC. AD and C. So this triangle here. So since we got this as a 33,7, and they told us that this is a pyrogram according to the information that was given. So if it's a parallelogram, which means even this bottom part must be a 33.7 because the diagonal bisects these angles. If that is true, we can find this distance AD, and we can also get the distance DC. What did they tell us? They told us that the distance was root 65. Okay, if that is a root 65, so which means we have this as a root 65. We only need the distance of AD. Okay, so we shall say AD will be the square root of -3 minus -2 squared. K was a 4 minus -4 squared. And I punch that into the calculator of -3 squared. What is happening? Plus, I'm getting also root 65. Does that make sense though? 3 minus minus, which is a 1, that is 8. Getting root 65. I don't know if that's going to make sense. If that is going to make sense. Because what I don't want to use is that other angle. Yeah, let's see, guys. It's a -3 minus -2, 4 minus -4. Let me just confirm it, guys, just to be sure. Minus -2 squared plus 4 minus -1. It's a 4. We square that, which is root 65. No, it's okay. Let's go with it and say the area now is going to be a half times this root 65 times that root 65, and then the sine of these angles combined. So 33.7 times 2 is giving me 67.4. So when I punch that into the calculator, 67.4. I'm getting 30,0000. So which means it's just 30 units squared. It's okay, guys. That will be the area that is needed. Then that is question 3. Then question 4, dealing with the circles. Telling us the diagram below, the equation of the circle N is given as that. And then QT is a tangent to the circle T. T and P is the diameter of the circle. Have point P, which is 5, and 4 lies on the circle. All right. Then the question is that, can we write the equation of the circle in this other format? And so in that format, all they want us to do is complete the squares. Okay, so how do we complete the squares? That we need to know. So we're going to say x squared plus y squared minus 4x minus 2y minus 13 is equal to 0. So step number 1, some people prefer to move the 13 that side. But it's no big deal. You can even work with it when it's this side. So if I take it that side, say minus 4x, why don't I just try to rearrange as well? So it's x squared minus 4x plus y squared minus 2y must give me a 13. Then when we are completing the squares, we just look at the b value for x and y. Okay, so the b value there is a 4. So we're going to half it, and then we square it. So that's going to be x squared minus 4x, a half of this. That's going to be 2, but squared. I'll do the same thing. This is y squared minus 2y, a half of that is just 1 when I square that, is equal to 13. Now, since I'm introducing these squares, I must also do the same on the right-hand side. So that's going to be a 2 squared plus a 1 squared. Then that represents our quadratics, and then you can factorize that. So that's going to be x minus 2. So x with this sign, and then that number that you squared. And then plus, we're saying y with this sign, and then the number that we squared must give us, this is 13 plus 4, that's 17 plus 1 is giving us 18. So that is how we would have completed the squares. Alternatively, what we are always told, just as a quick approach, just x and then y, just get a half of this with a sign. So it's a negative with a 2. Then a half of this with a sign, -1, you square that. And then you just add those squares that side. You just get that fast, without going through this long process of breaking that down. Okay, then write down the coordinates of n, which is the center. So n is going to be 2 and then 1. We switch the signs, +2 and +1. Then they want the length nt. Nt is the radius, but remember this 18 of ours is the r squared. So for us to get r alone, you must get the square root of it. Okay, so nt is square root of 18, which is 3 root 2. If I was to simplify that. Then 4.3, determine the equation of the tangent QT. Tangent QT. So we know that since we have the coordinates here as 2, 1, we want the equation of the tangent. We need the coordinates of t first. And then after getting the coordinates of this, we also need the gradient of P.2. Then we shall be in position to get the equation of the tangent. Okay, so I'm going to start with determining the gradient. So I'll say m of P.2 is going to be 4 minus 1 over 5 minus 2. So that is a 3 over 3, which is a 1. Okay. Then the equation, from try the equation, remember it's y is equal, okay, y minus 1 is equal to 1 into x minus 2. Or you can use the mx plus c1. When I open that up, I'm having y is equal to x and that is x. I'm going to have a -2 and then a +1. So it's x minus 1. This is the equation of the diameter. But then this equation or this line is meeting the circle at 2 points. So I'm going to work with this and then the equation of the circle and solve them simultaneously. Let's go that side, it's 4.3. Okay, so we said x minus 2 squared, y minus 1 squared is equal to 18. And then we have y is equal to x minus 1. So where there is y, I'm representing that or substituting. So I'll open that, not yet as Let me just substitute. So I'm going to have x minus 1 minus 1, but squared is equal to 18. Open this up. I'll have x. Why should I waste a lot of time? Because I know that this is going to be also x minus 2 squared. So I have 2x minus 2 squared is equal to 18. Divide both sides by 2, x minus 2 squared is equal to 9. And then I find the square roots. So x minus 2 would be plus minus 3. When I move the 2 that side, x is a 5, which 5 is this one, the p. Oh, if I move the 2 with a negative, x is going to be a negative 1. Because this is going to be a 3 plus 2. It's going to be a negative 3 plus 2, which is negative 1. So we have the x coordinates. Okay. I have the x coordinate of this t, calling it a negative 1. Then let's get this negative 1 and substitute it into this equation of the line, which means y is negative 1 minus 1, which means the y is negative 2. So t is negative 1 and negative 2. Okay. Since we got the gradient to be 1, and we know that a tangent and the diameter, or tangent and radius, must be perpendicular from our Euclidean geometry. If that is true, which means the equation, the gradient of the tangent, okay, I'll just say gradient of the tangent must be negative 1. Since we say that the two gradients, the products of the two gradients must give us negative 1. So it's like a negative 1 times another gradient of the tangent must give us negative 1. This was a positive, sorry. And then when you divide both sides, you get a negative 1. Okay, so negative 1 as a gradient and the coordinates as that. So I'll say y minus minus 2 is equal to my gradient, which is negative 1, into x minus minus 1. I'm using this kind of format to determine the equation of the line. Like we said, mx plus c can also work perfectly well. So y plus 2 is equal to negative x minus 1. When I move the 2 that side, y is going to be negative x minus 3. That is what I'm getting for the equation of the tangent. If you have a quicker way, you can always share it with us. Thank you. Then 4.4, they are telling us that a circle with S, that is AB, touches the circle with N externally at point T. Just to refresh this, that I clear. Okay, so we have another circle that is touching at T. I don't know whether it's big or small, but it's fine. Let me use that. Okay, so if this is extended, that's going to be S with A and B. What they are telling us is that this tangent is tangent to both. If NS, the distance from here up to there, is 3nt, can we determine the coordinates of S? So guys, we got the coordinates of T, which were negative 1 and negative 2. Okay, we got the equation to be y is equal to negative x minus 1. And we also got the radius to be a 3 root 2. Okay. Let's go back and fix this, because I see that 3nt is in a wrong place, telling us that ns. Okay, guys, so with 4.4, what we're going to do, we said ns is 3nt. Okay, so if we square the ns, we're going to end up with 9nt squared. We're squaring it so that we simplify that whole thing. Okay. But since we already have, what is that thing? Remember, if this circle were to be drawn, that is n, it told us that this distance is 3nt. Okay, when you simplify the 3 times the 3 root 2, you get the 9 root 2. When you square that, that's how you're getting the 162. Okay. So this 9nt squared, okay. If we apply the distance formula, it's going to be a minus 2 squared plus b minus 1 squared must give us the 162. So we're looking at the distance from here up here. Remember our n was 21. So a minus 2 squared, b minus 1 squared. Okay, let's call that equation number 1. But we know that nt and qt, those are perpendicular lines. Okay. If they're perpendicular, the product or the gradient will be -1. So if this is perpendicular, even this line will be perpendicular. Remember, our t was a negative. Was it -1 or 2? No, it was a -2, a -1. So let's try to get the gradient of this and equate it to the gradient of that line that we got as a +1. So we're going to say b minus -2 over a minus -1 must give us 1. So b plus 2 over a plus 1 must give us a 1. Let's try to make b the subject, which is a minus 1. Or alternatively, even from that equation of the x minus 1, if you replace b and a, you just straight away get to that. Then we need to substitute this b with that. So it's a minus 2 squared plus b, which is a minus 1 squared, is equal to 162. Okay. Let's open this up. We have 2 into a minus 2 squared is equal to 162. Divide both sides. That's going to give us 81. Square root of 81 is plus minus 9. That's going to give us a minus 2. And then we can move the 8 to that side. So either a is 11 or a is going to be a -7. Okay. Then we substitute these values into that. So which means b is going to be the -7 minus 1, which is -8. So which means s is -7 and -8. All right. Question 5. They're telling us that in the diagram below, point P is this and it's having a reflex angle, which is 2 theta, as shown in the diagram. And we can see that it is in quadrant number 3. So one thing that we need to do, one thing that you need to remember is completing this triangle. So this -3 is for the x, and this -3√3 is for the y. Now we need to find the hypotenuse. That has to be our first priority. So from Pythagoras, we know it's x squared plus y squared. So I'm going to say square root of -3 squared plus -3√3 squared. Now punch that. We have -3 squared plus -3√3. That's squared. So that's giving me a 6. So remember, this answer of yours should never be negative in any way. You must always have positive values. Then from there, we can now answer the question of cos, because we know that cos is adjacent over the hypotenuse. So our adjacent is -3, and then the hypotenuse is a 6. So the answer becomes -half. All right, then they want the sine of theta. Sine of theta. So it will be your choice on how you come about with the sine theta. But remember, the question gave us a double angle. So we can use the double angle of cos, where we know that the cos of 2 theta from our formula page, let's just rush there. From the formula page, we can use this one. 1 minus 2 sine squared. So that's going to be 1 minus 2 sine squared theta. And let's try to make sine theta the subject. So it's going to be 2 sine squared theta is equal to 1 minus cos 2 theta. Then we can divide both sides and take square roots. And so sine theta is going to be the square root of 1 minus cos 2 theta over 2. When we substitute our cos 2 theta, which is -half, so it's going to be 1 minus -half over 2 under the square root. You can go bit by bit or just at once, no problem. Okay, we're dividing by 2. I'm getting a √3 over 2. So we need to see all these workings out. Then 5.2. They want us to simplify this. Okay. Let me just do it this side. 5.2. So we have cos squared 180 plus x. Cos squared 180 plus x. And then we also have a cos of -x. Okay. And then we multiplying by the tan x. Multiplied by the tan x. Multiplied by the cos of 90 plus x. So we need to apply our reduction rules. So 180 plus, that is quadrant number 3, where the cos is negative. So it's going to be negative cos x, but we're squaring it. And we say the cos of a negative angle is the same as the cos of a positive. So we ignore that and use it as a positive. we could change this, the tan, into something like sine x over cos. Okay, and then the cos of 90 plus, this must always give us a negative sine x, since those are complementary angles. So what we see is that this is going to give us a cos squared x. This is going to cancel that and that we have negative sine squared x. So cos squared x minus sine squared x, this is a double angle, of course. So that's the same as cos 2x. That's what I would get. Then consider the equation 5 tan theta minus 6 cos theta. Can we show that this equation can be written in this format? Now with this format, we are only seeing the signs there. We don't have a tan, we don't have a cos. So what I'm going to do, let's see. We have 5 tan theta. We are subtracting 6 cos theta is equal to 0. So this question would have also come in the form of, can you prove that this can also is the same as that? So step number 1, since we don't have a sign we don't have a cos or a tan by our answer, we need to change. That's going to be 5 sine theta cos theta minus 6 cos theta is equal to 0. Then we're going to multiply through by the cos. So cos theta times cos theta times cos theta. So this cancels. You have 5 sine theta minus 6. This is sine. Why am I saying sine so fast? That's cos squared. Theta is equal to 0. Then let's change the cos squared into sine. That's going to be 1 minus sine squared theta. Then just open this up. You'll have your 5 sine theta minus 6. And then this and this will give you plus 6 sine squared theta. Rearrange this. So it's a 6 sine squared theta plus a 5 sine theta minus 6 is equal to 0. I think that's what they had. It's a plus 5 sine minus 6. Correct. Then they want us to determine the general solution. So with general solution, since we've already changed these to just one trig ratio, then we can use the quadratic formula to determine our reference angles. Or we could just factorize it out. Whichever one would be quicker and easier. Okay. So if we use the quadratic formula, that's going to be our A, that's our B, and then that's our C. So if I try to use that quadratic formula, I substitute that. I have 6. Come on, I have 6. Okay. All right. Okay. So I'm having the first x. Now remember, our x's are representing the sine theta, because that is the x. So you can have sine theta as a negative 3 over 2, or the sine theta as a 2 over 3, after using the quadratic formula. B squared minus 4ac over 2a. This is minus b. When I substitute my 5 plus minus square root of the b, which is a 5 squared minus 4, the a is a 6, that's a negative 6 over 2 times 6. That's what I get. So then for the first reference angle, shift sine of -3/2. I'm getting -90 plus what. But by virtue of the fact that this is -1,5, it's going to give us an error. So it's not applicable when it comes to sine, because I'll be ending up with imaginary values or imaginary numbers. Okay, which means I'll be left with the 2/3. So the shift sine of 2/3 is giving me 41. Okay, so our reference angle is a 41,8, and this is quadrant 1. So we shall say 41,81 plus k times 360, which is the period, and then k is an element of integers. This is quadrant number 1. And then quadrant number 2, because we know that sine is also positive in that quadrant, it's 180 minus this 41,30. So 180 minus 41,81 plus k times 360. I simplify that, I'm getting 138 plus k times 360. K is an element of integers. So that's what would have been done. So start with the quadratic formula, the solutions. So this is not going to give us any solutions. And then we end up there. Okay, then 5.4. 5.4. 5.4, they want us to prove we have enough space down. Not that much. Can we prove that this is the same as that? Okay, let me just rewrite it again. To rewrite this again, as much as it's going to take a lot of time. But I remember this question was cut out last year. This question was cut out. But it's fine, let's give it a try. So we have a cos 2 alpha plus 77. Okay. And then you have a cos alpha plus 47. Okay, and then this is minus sine alpha plus 47. And then sine 2 alpha plus 283 is equal to cos alpha plus 30. Okay, so there's nothing much I can do about the first ratio, this one. I just need to play around with this. In which quadrant is 407? That is the first quadrant. And which angle? We know that first quadrant is the same as 360 plus theta. So which angle do I add to 360 to give me 407, which is a 47? So 47 plus 360 must give me this. So if I'm to reduce this, because now it's going to be a cos of 360 plus the 47 plus the alpha now. Okay. I'll keep my 2 alpha plus the 77. When I reduce that, I'm only going to be left with just the cos of this. Then I'm going to keep the alpha and the 47 there. Where do I find 283? 283 is in the third quadrant, which is 180 plus something. So 283 minus 180. I won't use that. That doesn't make sense, man. No, 283 is in the fourth quadrant, not third. Low. So 360 minus 283. It's 77. Okay, so that's the same as the sign of, remember, in the third quadrant, sorry, in the fourth quadrant, it's a 360 minus theta. So I'm going to say 360 minus our 77. Is it going to be minus again, the alpha? Yeah, it must be a minus. So that we keep it as a plus. All right. So let me just simplify that. So I'm going to have cos 2 alpha plus 77. And then I'll be left with a cos alpha plus 47 minus, I have the sine of alpha plus 47, and then the sine, this is gonna give me negative sine, because the sine is negative within the fourth quadrant. So it's a negative sine. I have alpha plus 77. So this negative and negative will make that a positive. So cos 2 alpha plus 77 times the cos alpha plus 47 plus the sine alpha plus 47, and then the sine alpha plus 77. So this is a compound angle, but it's a compound angle of cos. What happened? There was a 2 alpha, man. It's meant to be a 2 alpha somewhere here. So that this is also 2 alpha and 2 alpha. Okay, so then, because we can see 2 alpha 77, 2 alpha 77, alpha 47, alpha 47. So it's just a compound angle, of course. And if there's a plus, if I call this my A, and I call this my B, it's gonna be the same as cos of A minus B. Okay, so I'm gonna say cos of 2 alpha plus 77 minus, this is going to be alpha plus 47. Because when you open these compound angles, you end up with that. Then I can open this up. I have the cos 2 alpha plus 77 minus alpha minus 47. Then 2 alpha minus alpha, that will give us just an alpha. Then 77 minus 47 will give us a plus 13, which is the same as the right-hand side that they wanted. All right, so that is that. Then 5.5, they want us to solve for alpha and beta. The sine of 3 alpha minus beta is equal to 1 over root 2. If 3 alpha minus beta is between 90 and 270, quadrant 2 or 3. And then at the same time, they're telling us the tan 2 alpha plus beta is equal to this. So let's get rid of these ratios and just focus on the variables alone. So for me to get rid of this, I must find the shift sign of 1 over root 2. Okay. So what is 1 over root 2 shift sign? The arc sign of 1 over root 2 is going to be 45. but they're telling me that the focus is 90 and 270. That's where the focus is. So which angle is that going to be? We're seeing the sign to be positive here, the ratio to be positive, which means it's going to be in this second quadrant. And in this second quadrant, it's 180 minus. So I'm going to say 1 minus 45. So we can say that 3a minus beta is equal to the 180 minus 45. Remember, first step was to get the reference angle. When you subtract that, 3a minus beta will give us a 135. Then when you look at the tan is also positive. They're telling us with the same ratio. So between these intervals, where we find tan to be positive, it's in the third quadrant. Third quadrant is 180 plus. So what is the shift tan of 1 over root 3? Shift tan of 1 over, come on, root 3. I'm getting a 30. So here I'll say 180 plus 30, which will give me a 210. So I have 2 alpha plus beta is equal to 210. Then I can subtract the 2. Does that make, why am I saying minus here? Yes, it's a minus, because that's what they gave me. Then equation 1, equation 2. I can just plus this so that this dies out. So I have 5 alpha is equal to 135, and that I'm having 3, 4, 5. Divide both sides by 5. So 3, 4, 5, divide by 5. I'm getting a 69. Guys, getting 69. Okay. Then for me to get the beta, I can just go back to either equation 1 or equation 2. So if I use equation number 2, I'll have 2 times 69 plus beta must give me 210. So it's a 210 minus 2 times 69. That's 138. So 210 minus 138, I'm getting a 72 for beta. All right, so that is 5.5. Then question 6, which is the trig functions. In the diagram, we have f of x, 2 cos x, that is drawn in this interval. Can we draw the graph of g, which is negative tan x within this interval? So guys, it's up to you. Either you use your table or you use the calculator. Okay, whichever one just gives you the results quickest. So that is that. They don't have a g. I'm starting from negative 90. I'm ending at 180. And then the steps of it. What did I do wrong? Let's do it again. Table, that's the function. I'm starting at negative 90. I'm ending at 180. Steps of it. All right. So my calculator. Are you in the right mode? So I have a lot of values, but they seem to be too small. They're very, 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 very small. Something's wrong with my values. Because it's the same thing. Say negative 2. Oops. Perfect. Okay, so negative 90 is giving me a negative 1. Then negative 60 is an error. So which means that's an asymptote. Whenever we have errors by the tan, it's an asymptote. Then negative 30 is a positive one. 0 is a 0. Then 30 is negative 1. 60, it's an error. Then 90 is a 1, positive. 120 is a 0. 150 is a negative 1. And then 180 is an error, which means it's an asymptote. Okay, so remember the direction of the tan graphs, or the shape moves towards the asymptote. And then this can move towards, come there, and then towards the asymptote. And then this one will also do the same thing, just in the format, and then move towards the asymptote. Remember, the asymptote is at 180. Okay, so that is the G for Max. Then they're asking us to determine the period of G. Now remember, normal period of a tan graph is meant to be 180. But then the moment we have something extra there, it will affect the period. In other words, we can just divide the 180 with this. So if I get 180 divided by 3/2, it should give me 120. Is it 180 divided by 1,5? Come on, calculator. About 1,5. I'm getting 120. So my period is 120. So after 120 degrees, I should have a full graph of tan. All right, then 6.3. They want the values of x in the interval for which f is decreasing. Where is f? This is f. So where is f decreasing? So from this point, because that's the turning point, the maximum, it's slowing down towards 180. So we're going to say 0 is less x is less 180. Okay, so 0 is less x, and then it's less 180. So those are the values for which the graph is decreasing. Then use the graph of G to determine which values of x will G of x be greater or equal to 1. So where do we find the graph of G to be above positive 1? So we can see that from here, because that's a 1. So this area, the G is above 1. Same story here, the G is above 1. So we can talk about the interval of negative 60 and negative 30, or 60 and 90. Those are the intervals that they need. So we're saying negative 60 is less x or equal to x, less or equal to negative 30. And then the other one that we said was, why am I saying equal to with 60? Come on. It's an asymptote. It's not going to cut. So that is not meant to be there. Then this is going to be the same story. We have 60 is less x is less or equal to 90. Something like that. We'll give you the mass. Then 6.5. They're telling us that h is a function that is obtained by translating G 30 degrees to the right. Okay, they want the equation of h. So we are translating G. G is this tan graph. 30 units to the right, we're moving it in this direction. That's not really relevant to us now. But let's just look at the equation itself. So it's going to be negative tan. Remember, it was 3 over 2x. Now, if you shift the graph to the right, you shall subtract a bit from there. So that's going to be h of x is going to be negative tan 3 over 2 with the x, I'll say x minus 8. That would be my equation. Okay. Then if you want, you can open this up. That's if you want. But that is still perfect for me. If somebody opened it up, it will be 3 over 2x minus zeta 45. That is if everything's together, but this just enough for the 2 marks. Okay, question 7. The trig application, which is the 2D, 3D trig. They're telling us that in the diagram below, AB is a pole that is anchored by 2 cables at C and D. And B, C, D are just in the same horizontal plane. B, C, D, B, C, D, horizontal. Okay. And then the height of the rope is H. A is a theta. The angle between CAD is 2 theta. AC is the same as that, okay, indicated. Then they want us to determine one mega question. They want the distance CD. This distance is what they need between the 2 anchors in terms of H. So what I need to do, I can start by finding this distance, the AC, in terms of H. Because if I have this H, I have the theta, and then I have this 90. I can use the trig rules or the trig ratios. So this is the opposite, this is the hypotenuse. So we can use sine. So you can say the sine of theta is equal to the opposite, okay, which is H, over the hypotenuse, which is AC. Can make that over 1 and cross multiply, which means my AC is going to be H over the sine of theta. I don't need to name it, but it's fine. So this side is H over sine theta. So even this is H over sine theta. Now they want us to get the distance between. So for us to get this distance, we don't know this size, as much as we know that this angle must be the same as this angle. Okay. You can work it out that way. Whereby if this is 1, this is 2 theta, then these angles are going to be 180 minus 2 theta divided by 2, which is basically 90 minus theta. So this is a 90 minus theta. That's also a 90 minus theta. We can use that. And then we use the sine rule. I don't know, I think that's quicker than using the cosine rule, because squaring those things, it will be something else, but let's see. Yeah, I think that's better. So after getting this, let's say that B is the same as D. Angles opposite, equal sides. And then we're saying 180 minus 2 theta over 2 must give us 90 minus theta. Okay, so A, noise B is equal to C. Why am I saying P? It's a D. Malumio. Okay, so D is the same as C, which is 90 minus theta. Then I'm going to apply my sine rule. Remember from the sine rule, we said if you have A over sine of A must give you C over sine of C, or B over sine of B. We're looking for the side, so I'll prefer using this kind of format. So I'm going to say CD over the sine of 2 theta must give me my, if I use this, I can use this too, either this or that, doesn't matter. So let me use AB. AB. that is AB, which is h over sine theta, divided by the sine of 90 minus theta. Okay, so since I'm looking for CD, I can multiply both sides by sine 2 theta. So CD is going to be h over sine 2 theta times sine 2 theta over the sine of 90 minus theta. Then I can reduce this, which is h over sine theta. We know that the double angle of sine is 2 sine theta cos theta. When we simplify this with the reduction, that's going to give us just the cos theta. So this can cancel that. I'll be left with 2h cos theta over cos theta. And then the cos theta and the cos theta will also cancel, which means CD is twice h. I don't know, guys, but that's how I would have gone about it very fast, because that cosine rule was going to show me flames, because it's long and squaring the top and the bottom. But if you can use it, I'm not discouraging you. Please go for it. Question 8, Euclidean questions, are telling us that in the diagram below, points P, Q, R, and S are points on a circle with center O. UV is a tangent. Okay. This is it. And then PQW is 106. SP is the same as SR. This is produced to intersect at T. This is produced to create a W. All right. There we go. Then they ask us the first question, can we calculate with reasons? Let's reduce this. Will people see? That's better. So they want us to get PSR. PSR, this angle here. Now, one thing we need to know is that PSRQ is a cyclic quad because it is touching the circle. Okay. And this angle here is exterior. So we know that the exterior angles of a cyclic quad will be equal to the opposite interior. Okay. So I'm going to say that PSR is 106. Reason, exterior angle of a cyclic quad. That is the reason. Then they want us to get R3. So if this is 106, how do we get R3? We know that this side is the same as that side. So that's an isosceles triangle. So we're just going to say that R3 is the same as P4. So for me to get R3, I'll get 180 minus the 106, and then I'll divide by 2. So 180 minus 106 divided by 2, which is a 37. So my R3 is 37. So reason for that will be angles opposite equal sides. Angles opposite equal sides. Then we have this as 37. We have this as 37 as well. Then next, they want P5. P5. Where are you? So when you look at this P5, remember this is a tangent. And then this triangle covers the whole or touches the circle. So you can use a tan chord because this is the tangent, this is the chord, and the angle opposite. So I'm going to say P5 is a 37. Come on, why are you rushing? This is a 37 because of the tan chord theorem. And then they want us to get O1. So if this is a 37, they want us to get this angle O1. Now O1 is at the center. Which angle is at the circumference of O1? It will be this 106. Because this other part of the O will correspond with the Q, other part of Q. So this O1 must correspond with this. So the angle at the center has to be twice. So this is going to be 2 times 106. Okay, that is for O1. And then that is going to give us, I think, 212. Okay, we're saying 2 times 106, which is 212. Reason, angle at the center. Angle at the center must be twice angle at the circumference. Okay, and then P3. How do we get the P3? You want this angle here. So I think we can use the same thing. We can say that P3 is the same as R2. Angles opposite, equal sides, because we know that this is a radius and then that's also a radius. Or you can tell us that OR is the same as OP, because of radii. If that is true, if this is 212, we need to find the other angle that is shorting to make it 360. So 360 minus 212. What do we get? 360 minus 212, I'm having 148. Okay, so this is 148. Then for me to get this missing 2, I'll get my 180 minus 148, divide by 2. 180 minus 148, divide by 2, which means it's a 16 each. That is 16 degrees. I don't know. Am I using a long process to get 16? Was there a shorter way? Why are the marks too small? Yeah, there was actually a shorter way. Because if you get the, what is this? We say 21 plus 148. When you divide this by 2, you get your 72. And then what is shorting of 72 to give you 90? Because we know that this is already 90. Yeah, that made sense, but it's fine. We move. 8.2. In the diagram below, A, B, C, D, and E are points on the circle centered O, telling us that AC is AC. OC and ED are drawn. BC is the same as CD. Let CED be X. Yeah, these are X. And then they want us to determine 2 other angles that are equal to X. So when you look at your bow tie, this is X, this must also be X. So you tell us A2 is going to be X. And what is going to be the reason? What's going to be the reason? It's angles subtended by the same chord, or angles in the same segment. Doesn't matter. So angles in the same segment. Or equal chords subtend equal angles would be the same story. So that is A2. But they're telling us that this A2 must be equal to some other angle because this side is equal to this side. So if this side is equal to this side, which means the angles that are also created by this side will be the same. So which means A1 is also going to be equal to X. What is the reason? We're saying equal chords, they subtend equal angles. So A2 and A1. And then those are reasons. Then determine ABC. Determine ABC. They want this angle in terms of X. What do we see there? It's a 3-mark question. ABC in terms of X. All I see is ABCD is a cyclic quad. You know that this is a 90. I think I should start from there. How do people see that? If I just say that my angle ACD is a 90, angle in a semicircle. Angle in a semicircle. So if that is a 90, then what is D1? D1 is going to be 90 minus X because of angles in a triangle. Okay. So if D1 is 90 minus X, we know that D1 and B are opposite angles of this cyclic quad. Okay, so the opposite angles have to be supplementary. So I'm going to say B1 plus the 90 minus X must give me 180 degrees. Why am I saying B1 is just a P? Okay, let's just write it out for people nicely. Okay, we're saying B plus D1 must give us 180, the opposite angles of a cyclic quad. Okay, so B plus the 90 minus X must give us 180. Then we move this 90 that side, we move the X that side, which means B is going to be 90 plus X. I think it's fair enough. Then they want us to prove that AB is parallel to CO. AB, this line, is parallel to CO. So for us to do that, you need to find those angles that are created by parallel lines, either co-interior, alternate, or corresponding. Okay. So if we got this as a 90 minus X, which means C3 and 4 will also be 90 minus X. Let me just write it somewhere here. Okay, this is 8.20. We're saying C3 plus C4 will be 90 minus X. Reason angles opposite, equal sides. Why are we saying that? We know that OC is the same as the OD because both of them are radii. Then if it's a 90 minus X and 90 minus X, then what is O1? Alternatively, helps God. Why did I even go through this? We're seeing that this O1 from this X, O1 is twice X. Angle at the center. We got twice angle at the circumference. Why? If this is a 2X and the whole of this, the whole of A is 2X. Okay, therefore, you can just recognize that AB is parallel to CO. Reason, the converse of corresponding angles. The converse of corresponding angles. Whoa, what was I looking at for me to go calculate those things? But it's okay, guys. You would still get the same things. You would still get the same marks and you would end up still with the same results. If you use the 90 minus X and all of that, just the same thing. Whichever format you use, you still get the results. Or someone could also see that, oh, this is a radius, so which means this is X. And then they use this as alternate angles. Bingo. All right, then question number 9. In the diagram below, BOA is a diameter. B is a tangent. There we go. And then EA cuts the circle at D. All right. F is the midpoint. Thank you. Prove by giving reasons. There we go. There we go. That OBEF is a cyclic chord. OBEF. Can we prove? Did they tell us any parallel lines? No. How do we prove that that is a cyclic chord? So remember, when you're proving a cyclic chord, one, either the opposite sides must be supplementary, or the opposite angles, not sides, sorry. Then you could look out for also the exterior angle. And then we could alternatively look out for the bow tie. Something like that. If just one pair of angles is equal, then we can draw a conclusion that the figure is a cyclic chord. Okay. So where do we start from? OB, EF. What do people see? What do people think? Is there anything they give us? We only have a tangent. Not so. Yes, just a tangent. If it's a tangent, we know that this is going to be a 90 degree because of the tan radius. Does that make sense though? That's what I'm thinking. And radius. Then it's okay. Let me just write that down and say that B1 and 2, which is the same as B, is 90. The tangent perpendicular with the radius. Then we can see that this is the center and this is a chord. So a line from the center perpendicular to the coordinate. Did they tell us that? I don't know. I don't know. Did they talk about a midpoint? Anyway, the diameter, blah, 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 blah. Yes, they talked about the midpoint. F is the midpoint. Thank you. So we have it. So we're going to say that F2 is also 90. Reason, line from the center. It must be perpendicular to the chord. Line from the center to the midpoint of a chord must bisect the chord. Line from the center. This reason is vague, man. Reframe it, bruh. Okay, we're saying line from the center. Line from the center. Bisecting the chord is perpendicular to the chord. So F2 is a 90. Now, if that is a 90 and then this is a 90, so we're seeing that the opposite angles are supplementary. So F2 plus B gives us 180. Therefore, OBEF is a cyclic chord. And the reason is going to be the converse of the opposite angles. The converse of the opposite angles. All right. Should we add the word cyclic? It's okay, no problem. No problem of a cyclic chord. People must be happy. All right. So that is 9.1.1. Then 9.1.2, they need us to prove that ADB is similar to BDE. Let me use different colors. ADB is macula triangle. Is it macula or macula? Macula one. And then BDE, is small one. Can we prove? Can we prove? Can we prove? that they are similar. So when you're proving similarity, just look out for the angles in most cases. So which angles do we see that are going to be the same? So I can see from this triangle that D1 is going to be the same as D2, because D1, number 1 is a 90 degree. Why? Angle in a semicircle. Okay, because this is a diameter. So the angle that is opposite the diameter must always be 90. That's a 90, which means D2 is also 90, angles on a line. Okay, so D2 is a 90, angles on a line. Therefore, D1 is the same as D2. All right, so that is fact number 1. And then the other fact that we see is what do we see? Both sides are, okay, both triangles are having this one side that is equal. So which means the angle that is opposite to those sides will be the same. So E must be the same as A. So I'm going to say E is the same as A. Reason, you can say equal chords. They There's nothing like that. You can just say angles opposite equal sides. I don't know. What would be the best reason, guys? I don't know. D1 is D2. That's fine. Saying E and A. But refusing that it can be E and A. Okay, I'll take it out. I'll take that out. Okay, let's see. We proved the turn code somewhere. Eh? Oh, we didn't, but we can prove. We can prove it. It's not true. This one of the equal sides, we are rejecting it. It's fine. I've taken it out. My apologies. So let's take the turn code. So this and that. So B2 is the same as A. Correct now. Turn code. So B2 is the same as A because of the turn code. And then, which means this angle E must be the same as B1. E must be the same as B1. The reason is going to be the remaining angle. The remaining angle of the triangle. So if we have 3 facts, then we can draw the conclusion. Therefore, ADB is similar to BDA. Reason, normally use angle, as well as the angle. So conclusion, and then the reason must be given. And then they want us to prove again that OB is a tangent to the circle passing through BDE. B, D, and E. So if we have another circle that is passing through these points, forgive my drawings. If we assume that's a circle, they want us to prove that OB, where is OB? This line is a tangent. So since we said that B1 is the same as E from the previous question, which automatically makes this a tangent, and it will be the converse of the turn chord. Okay, so what you need to tell us is that your B1, now Lord, where am I going to write this? First. Can write it on top there. It's 9.1.3. Don't worry. That's 9.1.3. We're saying B1 is the same as E. We proved that from the previous question. Therefore, OB is a tangent. The reason is going to be the converse of the tan chord. All right, so that is question number 9, and then question number 9.2. Let me take this out. 9.2. 9.2. They want us to prove that OF squared is given as AD times DE over 4. Why is it a square? So if we have squares involved, what's happening? Are we going to use Pythagoras? I don't know. Are we going to use the theorem? I don't know. Let's see. So OF. You want us to prove that OF squared is equal to AD. This distance times the DE. The distance. How do we go about that? We can use since we proved that these triangles are similar, I think we can just use the same approach. And what that is going to be is this side and then that side and so on. Okay, so what did we say? We say that AD, if we get our AD and then divide it by the BT, this must give us the DB, or BD, same thing. And then I'm going to divide that by the DE. Because I'm trying to compare the ratios using the similar triangles. Then if that is true, we can do the cross multiplication so that we have BD squared is equal to AD times DE. Okay. But one thing we know is that our AD is twice the DE. Okay, we're saying AD is twice the DE. The reason as to I'm using DE is because question does not have AE. So remember, this is a midpoint. So this must be 2 times, or must be a half. So AD is twice just one of them, which is okay. So if I try to substitute that, so BD squared is equal to my AD now, which is 2DE times another DE now. We are finished now. We are finished. Is that true? No, man. What am I doing? Where am I even going? That side of the midpoint. Remember, we've proved. Did we prove? No, we didn't prove. But we saw this is a line from the center. That's a 90. This is a 90. Automatically, these lines will be parallel. Okay. And if those lines are parallel from these theorems of ours, this must be a half of that. This is a half of that from the midpoint theorem. Yeah, it's making sense now. So BD, this is out. That's out. So we said BD squared is equal to AD times DE. So BD is twice OF. And then we just square it. So BD squared is going to be 4OA squared. And then substitute. So 4OA squared is equal to AD times the DE. then divide both sides by 4. So AD times DE over 4. All right, then question number 10. They just want us to prove this theorem. So in this diagram, ABC is shown or drawn, and then D is a point on AB, and then E is a point on AC, such that these two lines are parallel. Okay. Can we use the diagram below to prove the theorem that says AD over DB same as AE over EC? So guys, in such cases, we need to do constructions. It's a must. Okay. So what constructions do we do? Just from this end to that end, and then from this end to that end. Then also we need to construct from this end, we create a height that is perpendicular. And then also a height that is perpendicular. So if I call the first height maybe H, and then I call that height K. Okay. So constructions, we said it's a must. Just construct. You get a mark at least for constructing. Then let's do the proving now. So when you're proving, we always look at the areas. Okay. Just make this there. Okay, so we're going to say that the area, if we look at the area of triangle ADE, let me just focus on this top triangle first. Okay. Over the area of the DEB. But this let me just highlight it. Let's see this triangle lines together with this triangle. Okay, over the area of DBE. So that's a half times the base. So with my top triangle, let me. Okay, so we have 16A plus 32. That's going to give us 48A is equal to 96. Then 96 divided by, oh, that's a 2. I'm not mistaken. Yeah. So that's a 2. Then I'll get this 2, replace it there. So which means 128 times 2, we get the 256. Okay. So that is how that question would have been done. Okay. Then question number 9. Okay. You're telling us that the graph of h, which is negative x cubed plus x squared plus bx plus c sketched below, give us the values of a and b to be 6 and 0, which are the turning points. Then t is 3 and y is a point on h, and the graph of h passes through the origin. Okay. So having read that, they're telling us to show that a will be a 12 and b will be a negative 36. Okay, so we have number 1. B is a turning point. And also A is a turning point. Okay. Then we know that since the graph is passing through the origin, the C is going to fall out since C is going to be 0. So we only going to be having negative x cubed plus ax squared plus bx. Okay. If I use this point first, and then I substitute. So 0 is equal to, what is 6 cubed? Which is 216 plus 6 squared. It's going to be a 36a plus 6b. And I just make this an equation. I'll have 36a plus 6b must give me 216 positive. I can divide through by 6. 6a plus a b must give us, we can get 36, which is true. Then make b the subject, which is 36 minus 60. Cover the first equation. And then marks are there. So if that is the first, there are 3 marks. Oh, why are we doing? Okay, it's fine. Let's see if we can get them. Then let's find the first derivative. First derivative, which is dy dx. That's going to be negative 3x squared plus 2ax plus a b must give us a 0. Okay, having done that, I feel like this is a long route. Yeah, it's a long route, but it's fine. Let's see. When I replace x with a 6, that's going to be negative 3 times 36, which is 108. It's negative 108 plus 2 times 6, which is 12a plus a b must give us a 0. But we said our b is this. So negative 108 plus 12a plus 36 minus 6a must give us a 0. So this and this is going to give us a 6a. Negative 108 plus 36, getting a 72. Then I'll divide both sides by, wait a minute. This is positive 6. That's a negative. Okay. So 72 divided by 6, we get 12 for A. Then I can replace this 12 here. And then my B is going to be negative 36. Okay, so that is one way of getting that, as much as the marks look too small for all that I've done. Alternative number 2 could be using the vector method. Since we have this as a turning point and an intercept as well, which means I'm going to have x minus 6 squared. And then this point also is an intercept with the root, which means I can also have x minus 0. Must give me a 0. If I try to open this, I'll have x squared minus 36. Oh, 36, man. It's 12x plus a 36. And then I'm multiplying by x, which is x cubed. Something's off here. Because with this opening, it's meant to be negative. It's fine. Let me keep an a there, just in case. Okay, x cubed minus 12x squared plus a 36x. That is my y. Then if I try to substitute 6 and 0, is it going to make sense? Because now this is meant, with this opening, the A is meant to be a negative. That's what I'm saying. With the way they go, it's already here. What's wrong with me? So that's a negative. Okay, so if that's a negative, then it's negative x cubed plus 12x squared minus 36. I think we can use that and then get those answers directly. Whichever way, all we need are the answers. Then they want the coordinates of A. We found the first derivative, didn't we? It's fine. Let me just find it again. So coordinates of A, we need the first derivative, which is going to be dx, which is negative 3x squared plus a 24x minus a 36 is equal to 0. And then we solve using either the quadratic or the vector method. You can even start by dividing 2 by 3 if you want. So if I use my quadratic, that is negative 3, we have x squared plus 24 minus 36. Getting x as a 2 or x as a 6. So since we're focusing on A is going to be a 2. And get this 2, we replace it into the original. So when that happens, our y that we end up with is going to be negative 2 cubed. That's correct. Plus 12 times 2 squared minus 36 times 2. I'm getting negative 32. Okay, so negative 32 becomes the answer. Then they want us to get the value of y around about here. So if x is 3, what is y? So just replace that. Negative, we have 3 squared, no, 3 cubed, plus 12 times 3 squared, minus 36 times 3. Okay, so that is giving me negative 27. And they're asking us, is this graph concave up or down at point T? Okay. What do you think, guys? So we need to find the second derivative. And then at the second derivative, where there's x, we're going to replace it with a 3. So this is going to be, let me just say f double prime x. That's going to be negative 6x plus a 24. When I replace x with a 3, it's going to be 6 times 3 negative plus a 24, which is a 6, because that's negative 18 plus 24, which is a 6. We can see that 6 is greater than 0. Okay, so which means the graph is concave up. So we can say graph is concave up, since the second derivative of x, let's put 3, is 6, which is greater than 0. Okay, just at point B. Then determine the coordinates of the point of inflection. So the point of inflection is Okay, so we're saying for the point of inflection, we need to find the second derivative. We need to solve, we need to find the second derivative and equate it to 0, which we got. Okay, so we said negative 6x plus 24 must be equal to 0. Move the 24 that side, negative 6x is equal to negative 24, which means x is a 4. Then we need to get this 4 and then substitute it into the original. So we're going to have negative 4 cubed plus 12 times 4 squared minus 36 times 4. And then that is going to give us negative 16. So which means the point of inflection is 4 and negative 16. Number 10, which is also calculus. They're telling us that a hotel has 72 rooms that it can let to clients. The daily rent per room is 500. Then if the rent is now increased by 100 rand per day, 2 rooms are going to be left vacant. And then the rent is around X per room per day. X must be greater than 500. Can we show that the total daily income is given by that? So what we need to know is we need to set up equations or expressions just for what might be happening here. So an example, if you look at the rooms and the income that is coming through. An example, if I talk about rent being 500, and then there was another scenario where they said if the rent is increased, so if we increase it, it's going to be 600. So what's going to happen? How many rooms are there that are rented? We're saying there are 72 rooms. Okay, and then if the rent was increased to 600, then it will only be 70 rooms available. That's all. Yeah. Then what would be the income? What total will be collected? So if it's 600, that's going to be, does it make sense though? Because it is 600 by 500. The rent is 500. Now the rent is 6. With this much. Let's see what we have. So what we're saying is that originally, if we have 500 and all rooms are rented out, it would give us the 36,000. And then if it is 600 and only 2 rooms are left empty, we could have the 42,000. Okay, so how do we now work this out? Where X is greater than 500. So we need to look for the total increase or the rate at which the increase is taking place. So we can say if we have X minus 500 over 100. Okay. X minus 500 over 500. And then this is going to be multiplied by okay, so I'm going to say 7.2 minus the rate that is causing everything to decrease, because now if 2 rooms are left vacant, then the rate kind of decreases. If we try to open this up, it's going to be 7.2 minus what's 2 times X? That's going to be 2 82x minus 1000. We're dividing it by, no, this must be plus. We're dividing it by 100. Is that true? Yes, it's true. Then if we divide that, it's going to be so 72 minus, I'll say 2x over 100, I'll say x over 50 in this case, plus now 1000 divided by 100, that's going to be a 10, and then 72 plus 10, that's going to be 82. What happened to the x? I don't know. We shall see. 82 minus x over 50. Okay, but now all this again must be multiplied by the number or by the income that is increasing. So we get the 82x minus x squared over 50. Then 10.2, they want us to get the maximum daily income. So with maximum daily income, we have to differentiate. We need to differentiate that. So if we differentiate that, that's going to give us 82 minus x over 25. Equate this to 0. Move that aside, so x over 25 is equal to 82. Then multiply both sides by 25. So 82 times 25, getting 2050. So that is the daily income. Question 11. Telling us events A and B are mutually exclusive. So mutually exclusive simply means they cannot happen at the same time together. Probability of B is twice probability of A, and probability of A or B is that calculate B. So from the addition rule, you know that probability of A plus probability of B minus probability of A and B. But for mutually exclusive, this whole part is a 0, so it doesn't count. Let's substitute A or B is 0.57 is equal to our A. Let's leave it as A. And then our B is twice A. And then 1A plus 2A's, those are 3 PA's, is equal to 0.57. So if we can find the A, which is 0.57 divided by 3, that gives me 0.19. Then we need to just substitute this to get the B, which is 2 times 0.19. And then that must give us 0.38. Okay. Then 11.2, they're telling us a box of 45 letters is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective. 2 calculators are selected at random from the box, the first one not being replaced before the second one. What is the probability that the first calculator chosen is not defective? So 5 of the calculators are defective. So for the remaining ones that are not defective will be 40 minus 5, which is 35. Okay, we'll divide by 40. 35 divided by 40, we simplify that, and give it as a 0.875. Or you simplify and give it as a common fraction. Okay, then what is the probability that if 2 calculators are selected, one calculator is defective and the other is not? So if we were to draw just a simple tree diagram, defective, not defective, then defective and not defective, defective and not defective. Okay, so for the first part of it being defective, it will be 5 over 40. We're saying 35 over 40. And then if it was defective and then another one is defective, then it's going to be 4/39. And then okay, so we have 4 plus 3, which gives us a total of 7. So 7 factorial. Just use your calculator and find that. So that's going to be 5040. That's the answer. Then they're asking us that if two particular books must be placed next to each other, in how many different ways can you arrange the books? So if we have 1, 2, 3, 4, 5, 6, 7, they're telling us if two books can be placed together, in how many positions can we place them? So it's going to be position number 1, position number 2, position number 3, position number 4, position number 5, position number 6. So in other words, we shall have 6 different positions to place these two books. Okay. Times the arrangement of the two books. They can switch. Maybe book 1 and book 2. 2 can come first and then 1 can come next. So that's going to be 2 factorial. Then how many different ways can you arrange the books and show? So 6 factorial times 2 factorial. So from my calculator, we have in 1440. Okay. Then if all the economics books must be placed next to one another, and all the life science books must be placed next to one another, in how many different ways would you be able to arrange the shelves? Now, step number 1. We have, let's see, 2, 3, 4, 5, 6, 7. We have 4 books that are going to move as a block. And I see it's just one position that we can, no, it's not one. Okay, that's 1. You can have the second one. Okay, 4. And have this as a 4. And have this as a 4. But will it accommodate the other ones? Because now that's one other thing that we need to bear into mind or into consideration. So I'm just going to say the 4 books and switch within themselves, because it's not only the economics books that we're focusing on. So I'm going to have 4 factorial, and then with the life sciences, which are 3, I'll also say 3 factorial. And then the 2 books can sit together, because this clearly is not going to work of the shifting. So it's only one kind of arrangement for 4, one arrangement for 3, and then the books can switch within themselves. Okay, so we're saying this is not working. It's just 4 factorial within the economics books times 3 factorial within the life science books times 2. And then when I multiply that together, I'm getting 288. Thank you very much, guys. Let's meet in paper 2.